All right, now we're getting into the good stuff, you guys. Get a little trig going on. So the first thing we're going to do is just backtrack and make sure that we have a good basic working knowledge of our inverse trig. That's the first thing we're going to take care of. So I already have out of your book these images uploaded here so that we can go right from here and just see what it looks like. Let me get my pointer going. Okay, so let's focus on sine first. So the first graph I have, let me get red going on here, is just my regular sine function. It is going from down here, my minimum of negative pi over 2. You follow along and you come up here to pi over 2. I'm talking about the domain. So my domain is going from negative pi over 2 to pi over 2, right? And then my range, as we know, hits right here from -1 up to 1. And then this is just that periodic function, right? It just keeps going on and on forever. But in order to restrict my domain, like what we talked about with inverse functions, right? If my function kept going on like this, as soon as I crossed over that max, I wouldn't have a function anymore. So I have to restrict this domain. So my domain is restricted from between negative pi over 2 to pi over 2. All right. Then we have our y equals x line, right? So my inverse function goes from here to here. So I've got inverse, and it's going to come right on up like that. Remember, we talked about also with our inverse functions, whatever this point is, you swap those x's and y's. So if I have the coordinate point here, which is pi over 2, 1, my coordinate point over here is 1 pi over 2. You see that? Okay, so that's my inverse, which also means if my domain is restricted here to negative pi over 2 to pi over 2, that means my output of my inverse sine, oops, I didn't even have that there. My output then of my inverse sine is going to be from negative pi over 2 to pi over 2. So back to that unit circle. You guys got to know your unit circle. When I'm talking about inverse sine, my output or my range, let's put that in here, is going to go from negative pi over 2 to pi over 2. All right, so it does go right around the 0 here that we're looking at. It just makes it nice and easy. So my output, my answers available, the angles that my answers can be for inverse sine. I don't know how else to say that, lots of different ways. But my answers there for my inverse sine can only go on the right side of this unit circle from negative pi over 2 to pi over 2. All right, inverse trig. So this is just taking it out of your prereq trig class. All right? Okay. So all inverse trig, not just because we're in calculus, you got that out of trig class and we're just moving forward with it. Okay. So cosine, same thing, they have to be restricted. So I have, starting up here at 1, you're taking it down here to pi before, oopsie daisy, right? This same thing is happening. It's this periodic function that can go on and on and on. So we have to restrict that domain here from 0 to pi, which means my output goes up from 0 to pi for my inverse cosine, right? So we've got my inverse cosine, and it's that same kind of deal. Here is my y is equal to x. So if I have this point right here, I've got this point right here, right? Here's my point 0, 1, so I have the point 1, 0. And then same thing with my pi up here. So that's just my inverse. And so the kicker to this is the fact that I have to restrict my domain. When you restrict your domain, then you have that same restriction as your output value for your inverse function. So sine output can only go from negative pi over 2 to pi over 2. Cosine output or range is restricted up here from 0 to pi. Okay. So with those restrictions, then that happens. So sine, cosine, two super common ones, and let's look at tangent. Sine, cosine, and tangent, right? Those are our three biggies. If I'm looking at my actual tangent function here, we have our asymptote at pi over 2 and negative pi over 2. We have asymptotes. But look at what's happening. My function goes to infinity. So my output, my range for my regular tangent function is infinite. My domain is restricted here to negative pi over 2 to pi over 2, right? Which means whenever I have my inverse that I'm looking at, go to blue. So I'm looking at my inverse here. This goes on and on up to these asymptotes. So what do you notice as my domain of my inverse trig? It's infinite. Yes. However, my output, right, my range here for my output, well, I don't have that drawn on. Well, let's put it on. Is going to go from negative pi over 2 to pi over 2, the same as sine. Same as sine, right? So my output for sine, let's swing this in, my range or my output. For both sine and tangent is from negative pi over 2 to pi over 2. My output then for cosine is the top up there from 0 to pi. All right? You need to know that because when you go to evaluate these expressions, such as, here's example 1, says evaluate the following expressions. And we have A is inverse sine of the square root of 3 over 2. So anytime you do inverse trig, you are asking yourself the question, what angle gives me this output? That's what you're asking. What angle measurement, squeeze it in, that is restricted over here, restricted over here. So that angle measurement that is restricted, what angle measurement is going to give me that square root of 3 over 2? And what is that? I like to draw a little unit circle over here. So I know that I have square root of 3 over 2 is going to be up here at pi over 3. That's not look like a pi. I've got 1/2 square root of 3 over 2, and we know sine is the output. So this will be pi over 3. Right? And now here's how I do it, right? We have pi over 3 up here. I know for the pi over 3 and the pi over 6, one of them is going to be a 1/2. So I just think, okay, this hits my x-axis here at about 1/2. So I know that this x is 1/2. Over here at pi over 6, it hits my y at about 1/2. And then the other one's square root of 3 over 2. However you do that, that's up to you, right? But now that we're in Calc 2, the expectation is you've got this. I would like to find the inverse cosine of negative square root of 3 over 2. My x value is negative, and that works because cosine is on the top from 0 to pi. So where is cosine negative square root of 3 over 2? Over here, right? So this is going to be negative square root of 3 over 2, and 1/2. So we know it's a pi over 6. What is the pi over 6 over here on this side? 5 pi's over 6. Good. And again, however you find that. If you know that's 5 pi over 6, great. I use patterns and relationships. That's how I know trig. And we're going to be using tons and tons of trig. It doesn't go away. This is the trig semester. Calc 2 is trig heavy. This is pi, so I know that this is 6 pi's over 6, so 1 less would give me 5 pi. I don't go around counting that stuff. I think, what are my relationships of fractions? And then we can pull that off. There it is, right? Not bad. Let's do one more. That's about all we have room for here too, isn't it? Let's do another cosine. Inverse cosine of the cosine of 3 pi. Yeah, right? So if I'm looking at this, I say, so cosine and inverse cosine that we have, that's where we can pull that off. So I want to say cosine of 3 pi. How do I get to 3 pi? Yeah, I'm going to make a new thing here because I think it's getting too, that one's getting too junked up. So I can go all the way around as 2 pi, 1 more half. That's where I get the 3 pi. So what is the cosine? Remember, I'm not talking about inverse yet. I'm saying the cosine. So I can go as many swings around there as I want. I'm not restricted, just plain cosine. I only get restricted whenever I start doing inverse. But this coordinate point's -1, 0, so I know that this is a -1. Now I'm getting restricted. So whenever I'm looking at this restriction here, right, that's for cosine, then I'm restricted only to this top half for that. And inverse cosine over here is going to give me a what? Pi. And that's how it works. You see that? So I'm looking at that -1, swinging it around, and then I just get pi because of the restriction. Notice it ends up in the same place over here because those are inverses, right? But I have to have that restriction from 0 to pi whenever I have my inverse function. So my answer can't be 3 pi. It is just pi due to the restriction. Okay, good. There's a little trig review. Look that back over. Know these graphs. What the main thing is, what can my outputs be for that inverse? All right. Nice job.